Okay, so let's look at this next one. We have the sine of 2 theta equals a half. So there's a little bit of a difference on this one versus the first 7 we did. If you notice, the first 7 had that imaginary 1 in front of theta. This one has a 2 in front of theta. I'm dealing with a double angle. Now, here's the cool thing. How I start this problem is not any different than how I started the last 7 problems. First things first, I'm still going to make sure the trig function is by itself because technically I'm solving. So is my trig function by itself? Yes, it is. Second thing I'm going to do is find my reference angle. So let's go find that reference angle. Is the 1/2 on the 45, 45, 90 degree triangle, because that's my answer. Nope. Is the answer 1/2 on the 30, 60, 90 degree triangle? Yes, it is. So that's where I stop. This is where I draw my triangle, right? And yes, it's please draw this as many times as we need to. Don't go looking it up, because the more you look it up, the less you actually remember. The more you draw it, there's something about a connection between the hand and the brain. Okay, so draw it. So I'm drawing mine, I'm labeling mine. The question is, which angle that when I take the sine of it will give me a half? Well, that's 30 degrees, isn't it? That gives me 1/2. So my reference angle is 30 degrees, which is pi/6, isn't it? Good. And now I've got to figure out the quadrants. Good. So since I'm talking sine, sine is the x or the y. Good, the y. Since this answer is positive, I'm talking y being positive in which quadrants? Good, 1 and 2. So for quadrant 1, your theta is pi/6. In quadrant 2, your theta is, good, 5 pi/6. Some of you are getting the hang of it. Now, here's where the change comes in. Because normally, when we had the imaginary 1 in front of theta, we were done. But now, because there's a 2 in front of it, it changes it. So here's the deal. Technically, 2 theta would be equal to pi/6, wouldn't it? This whole angle would have to be replaced by pi/6, wouldn't it? Excellent. And then you would solve for theta by dividing by 2. Agreed? Okay. But here's something else that's happening. Because you are cutting your angle in half, it affects my entire circle. It also starts cutting the entire circle in half. So, in order for us to come up with all the angles that would be located in quadrant 1, I need to put into, or add to, this angle of pi/6. I need to add in the 2 pi, because that's a circle, right? That's the radian measurement of a full circle, and n. And you're like, well, what's n? N is the number of times you're running around the circle. If n is 0, we haven't gone anywhere yet. If n is 1, I'm going once around the circle. If n is 2, that's going the second time around the circle. Now, some authors use k. I don't care which variable they use. The point is, because you're taking your angle and now you have more than one angle measurement, and you're going to divide by 2 in this case, it affects the entire circle, not just the angle, but the entire circle. So now, let's take this and solve for theta. So to solve for theta, I am going to divide by 2 or multiply by 1/2. Agreed? That's the same thing, isn't it? So my theta would be equal to pi/12 plus pi n, right? Okay, so check it out. If n equals 0, then pi over 12 plus 0 is pi over 12. So my theta is pi over 12. Now remember, we're working under a restriction. At the very beginning, the restriction we're working under is that your theta has to be in this interval between 0 and 2 pi. Is pi over 12 in that interval? Yeah. And some of you are like, well, how do I know when it's not? My denominator is 12, isn't it? So get those denominators. Get those common denominators. Doesn't 2 pi equate to 24 pi over 12? Yeah. So if I go over 24 pi over 12, then we're done, right? Okay. This is not over 24 pi over 12, which means I'm going to go once around the circle. So theta would be equal to pi over 12 plus 1 pi, right? Okay. Add your fractions. I get 13 pi over 12. Is that still under 24 pi over 12? Yes, it is, which means I'm going to go again. N equals 2. I'm going to get theta equals pi over 12 plus 2 pi. Okay, I add those, and I already know it because now I'm adding a 2 pi to this guy. This is 25 pi over 12. That's not it. That's over the circle. This can't happen. So, interestingly enough, for quadrant 1, I have two solutions. I have theta being pi over 12 and theta being 13 pi over 12. And I know some of you are still asking yourself, how can that be? Let me show you. I need to get myself a little bit of board space here. Let me show you how that can be. Actually, let me erase this triangle because that would probably be better. All right. Sine of 2 times pi over 12 is supposed to be 1/2. When I multiply these two together, I get pi over 6, don't I? Good. If I take the sine of 2 times 13 pi over 12, multiplying these together, I get 13 pi over 6, don't I? Okay, improper fraction changes to a mixed number of 2 and 1/6 pi, isn't it? 2 times around the circle and another pi over 6. Pi over 6. That's how I know it's going to work. Cool? Okay. I know this is going to take a little bit of practice. When we have a coefficient of theta that's other than a 1, then it makes me do this work. It makes me put in this additional part of the problem, this additional, okay, I'm going to have to travel around the circle. Because we cut it in half, I ended up cutting the whole circle in half, which is why now I have 2 answers. Okay, here are 2 answers for us. Remember, we still had another quadrant, didn't we? We still had quadrant 2, didn't we? Okay, so let me erase this. Quadrant 2 was theta being 5 pi over 6, wasn't it? Okay, so quadrant 2, 5 pi over 6. But it's actually 2 theta being 5 pi over 6, isn't it? But because the 2 is here, it's going to affect my circle. I cut everything in half because I have to divide by 2, so I cut everything in half, which means theta is going to equal 5 pi over 12 plus pi times n. Okay, just like we did over here. If we're just starting around the circle, theta equals 5 pi over 12, doesn't it? Because this is 0. If I start moving once around the circle, theta is going to equal 5 pi over 12 plus 1 pi. Okay, you all do your addition, I'll do my addition. I get 17 pi over 12, which is still less than the 24 pi over 12. So I'm going to keep going. How about n is 2? You get theta equals 5 pi over 12 plus 2 pi. I already know that's over the circle, right? That's already beyond the 2 pi. I don't even have to add these two. It's already beyond 2 pi. So that's not going to work for us. So in this particular case, I have two answers for quadrant 2, as well as two answers for quadrant 1. I've got a total of 4 answers in this case. Why? This double angle cut the circle in half, which created more angles that were going to be in this restriction. I would suggest stopping this video, rewinding, starting again, listening to it again, and while you're doing that, I'm going to get another example. Okay, so check out this example. This one's an interesting looking one, but the procedure is still the same. Since I am solving a trig equation, I need to make sure my trig function is by itself. Is it? Excellent. And then I need to come up with the reference angle. Agreed? Okay, so in this particular case, I am talking about finding tangent of whatever equaling 1. Okay, so and that's 1 over 1, right? Is that your 45, 45, 90 degree triangle? Yeah, it is, because the tangent of 45 degrees is 1. And we've done enough of those problems that I'm hoping that you're starting to remember the simpler ones. The 45 degree is the simpler angle to remember. Why? Because sine and cosine are exactly the same result, and the tangent is a 1. So this is a 45 degree angle, which is pi over 4 radians, because remember, they want it in radian measurement. Okay, and now I've got to figure out the quadrants. Since I'm talking tangent, I'm talking both x and y, aren't I? So if it's x and y, and my answer is a positive answer, which quadrants am I speaking about? Good, definitely quadrant 1, because x and y are both positive. So positive divided by positive gives me positive. And definitely quadrant 3, because both are negative, and negative divided by negative is positive. So in quadrant 1, your theta is, excellent, pi over 4. And in quadrant 2, your theta is, quadrant 3, your theta is, good, 5 pi over 4. So, but this isn't just theta, is it? No, it's not. It's not just theta. So let me get rid of theta here, because your angle isn't theta. According to the problem, this whole thing is the angle. According to the original problem, theta over 2 minus pi over 4 is supposed to be pi over 4. And the same thing over here. Theta over 2 minus pi over 4 has to be equal to 5 pi over 4 for this to work. Okay, which means it's affecting the circle, and we need to put in the rotation of the circle a varying number of times. That's why the n is there. Okay, so I'm going to go to quadrant 1 over here, and I need to solve for theta. I need to get theta by itself. So all this is algebra, so follow along. I'm adding pi over 4 to both sides. So I can add pi over 4 to pi over 4, because they're the same, right? So that's 2 pi over 4, right, which is pi over 2. And then I've got to divide not divide in this case, I have to multiply everything by 2, don't I? So for you visual people, we're multiplying everything by 2, aren't we? Which means I have theta equaling pi plus 4 pi n. Remember, the restriction we're working under is, let me fix that. Your theta has to be between 0 and 2 pi. Include the 0, but not the 2 pi. So, n is going to equal 0, which means theta is equal to pi, isn't it? Because this becomes 0 when you plug in for 0, right? Which means it's in the restrictions, so I'm going to try again. And I'm going to start going once around the circle, which means theta equals pi plus 4 pi times 1, right? Well, that's 5 pi, isn't it? Well, that's clearly beyond 2 pi. So in this particular case, I have one solution. For quadrant 1, I've got one answer, and that's theta being equal to pi for this quadrant 1 angle. But remember, it's been manipulated based upon this junk inside here. Got it? Okay, so let me go to quadrant 3. Again, follow along. I have to add pi over 4 to both sides. Agreed? So we add like terms. So pi over 4 plus 5 pi over 4. Good. 6 pi over 4. Yes, 6 pi over 4 reduces to 3 pi over 2 plus 2 pi n. And then I've got to multiply everything by 2, don't I? So theta equals 3 pi plus 4 pi n. Right? Okay, so n is equal to 1, or pardon me, 0. Let's start with 0. That means theta equals 3 pi. Oh man, that's already over the restriction. I can't do that. How about, you know what, maybe go backwards? Then theta equals 3 pi minus 4 pi. That's a negative pi, which is still outside the restriction. That's not going to happen either. So in this particular case, I have one answer, one solution, and that's theta equaling pi. Cool? And you're like, I don't see it working. Let me show you. If I plug pi in for theta, so theta over 2 minus pi over 4, right? We said theta was pi. This would be pi over 2 minus pi over 4. This is 2 pi over 4 minus pi over 4, which is pi over 4, which is that quadrant 1 angle we said we were supposed to get. So I guess it worked. But there was nothing on this side. Nothing was going to get me that quadrant 3 angle. Cool? Hang in there. I'll be back with another example. Okay, so let's look at this next example. Same thing. I need the trig function by itself. Is it? Good. And now I need to find the reference angle, don't I? Okay, so something I'm noticing. My answer is just a 1, right? So sine refers to the y's. And I need the y to be just a 1. Is that the 45, 45, 90 degree triangle? No, because that's 1 over square root of 2, isn't it? Is that the 30, 60, 90? No, because it's either 1/2 or square root of 3 over 2. Is that your unit circle? Yes, this is a unit circle answer. Because I have my y, because sine refers to y, being just a 1, this is a unit circle answer. So, since this is a unit circle answer, where is the y a 1 on the unit circle? Good. This means your theta equals pi over 2. Right? Wonderful. However, it's not, and that's the only place, right? But it's not theta, it's 3 theta. So I have 3 theta equaling pi over 2. Well, as soon as the 3 got thrown in front, here comes this 2 pi n again, right? Because it's going to affect the circle. Okay, let's start solving for theta. So divide everything by 3. So that would be pi over 6 plus 2 pi n over 3, right? Okay, lovely. All right, let's talk about n equaling 0. Theta would just be pi over 6, wouldn't it? Because this goes away. How about n equaling 1? Theta would be pi over 6 plus 2 pi over 3. So now you got to add your fractions. Common denominator. This would give me pi over 6 plus 4 pi over 6, which gives me 5 pi over 6. Are we still good? Yes, we are, because remember, my restriction is theta having to be between 0 and 2 pi, and that's definitely in between there. So I'm going again. So theta equals pi over 6 plus, n is now 2. That'll make it 4 pi over 3, wouldn't it? Add fractions. Pi over 6 plus 8 pi over 6. 9 pi over 6. Oh, it reduces. 3 pi over 2. That's still in there, isn't it? I'm going again. N is 3. I got pi over 6 plus. If n is 3, what's going to happen between these two 3's? Yeah, they're going to cancel, so you're just going to get 2 pi. Oh, and that's already above 2 pi. So, we've got 3 solutions. We have theta equaling pi over 6, 5 pi over 6, and 3 pi over 2. You're like, do you always get that? Not always. Remember the last problem? I only actually had one answer because it was a little funky inside that parenthesis. But you know, this cut the circle into thirds, so I ended up with 3 answers here. The problem prior to that cut it in half. So for each of those quadrants, I got 2 answers. So something to think about. Hang in there. Got another. Okay, so let's look at this next problem. Do you notice you got 2 variables in it? I've got a cosine and I got a sine. So I need them both in the same variable, don't I? Okay, so here's what I've noticed from the last couple of problems. I really don't want to deal with a double angle. Because after I get the reference angle and I figure out the quadrants, that means I have to add that 2 pi n in there, which creates a lot more work for me. So if I'm trying to figure out which one of these I want to change, I want to change that one. I don't want to deal with a 2 in front of the theta. But I need to rewrite it so it has a sign. Yep, you've got 3 options, don't you? The one that I'm choosing is 1 minus 2 sine squared theta. Because isn't that one of the double angle identities for the cosine of 2 theta? Good. Plus the 10 sine squared theta equaling 7. I am going to collect like terms. Okay, so here we are. So we need to get the trig function by itself, right? That's always the first thing to do. So let's get that 1 on the other side. Let's divide by the 8. By the way, 6 over 8 reduces, doesn't it? And then I need to get rid of the square, which means, that's right, square root it. And when you square root it, how many answers do you get? Excellent, 2, plus and minus. So I get the square root of 3 over 2, don't I? Now here's one of the nice things. When I made this replacement and I collected like terms, I no longer had two trig functions. It came down to one trig function when I collected like terms. So yay for that, because this is making our lives a whole lot simpler. So trig function by itself. Reference angle is next. Let's see. The reference angle. Which triangle am I looking at with this answer of square root of 3 over 2? Excellent. The 30, 60, 90. So, again, draw this as many times as you need to. Please don't go look it up. Drawing it is going to help you remember it so much better. So, which angle? The 30 or the 60? Good, the 60, because I'm looking at sine. Opposite, right? So this is the 60 degree, which is pi over 3 radians, right? So after you figure out the reference angle, you've got to figure out your quadrants. So, since I'm talking sine, I'm talking the y. And since it's positive and negative, wow, I want the y to be positive and negative, which means you're dealing with all 4 quadrants, aren't you? Well, hold on. I'm changing my spacing. I'm dealing with all 4 quadrants. Now, in this case, gratefully, this is a 1 in front of theta, isn't it? Yay! I don't have to add that 2 pi n. Since there's a 1 here, I'm dealing with the normal circle. If I left this 2 in front of that theta, I would have to be cutting things in half. I don't have to do that. I can just leave a 1 here. Or this is a 1 right here, so I can just leave this as the answers that I know I'm supposed to, that I got like on the first 7 problems. So in quadrant 1, theta is pi over 3. So now you've got to figure out what theta is in the other 3 quadrants. You got to figure out the name of pi over 3 in these other 3 quadrants. Hopefully, you are writing down the same answers I am. Cool? Okay, got a couple more problems for you, but you're going to need your calculators. Okay, so let's look at these last 2 problems. They're asking us to use a calculator and to round to 2 decimal places. They still want it within a full circle. So, first things first, make sure your trig function is by itself. So number 12, my trig function is by itself. And now since I have to, since I need the reference angle next, I need to go to my calculator. And I need to figure out the, that's right, you've got to take the sine inverse of both sides in order to get theta by itself. So the sine inverse of 0.86. Are you with me? So here's the deal. You're going to have to punch that into your calculator. But since the restriction is still in radians, you need to make sure your calculator is in radian mode. And do you notice above the sine button, it says sine inverse. So you need to hit the second function to get there, don't you? Okay, so when I punched it in, I ended up with 1.04. Now, my process doesn't change. The sine function was already by itself. But because they're asking me to use decimals, I needed to do an extra step and actually figure out this inverse and get it in decimals. But here's the deal. I still need to come up with a reference angle. I need to know if this is actually my reference angle. Because remember, reference angles are first quadrant angles. I'm like, well, how do you know? Watch. Here's 0 radians, correct? Up here is supposed to be pi over 2, isn't it? Well, go to your calculator. What is pi divided by 2? 1.57, about. Over here is pi, isn't it? Well, you know what pi is as a decimal, 3.14, right? Down here is 3 pi over 2, isn't it? That's about 4.71. And back to 2 pi, which is about 6.28, right? We just got 1.04. Is 1.04 in quadrant 1? Yes, it is. So this is actually my reference angle. So that's good. And now, just like before, I need to decide my quadrants. So because I'm talking sine, that's the y's, and because this answer was positive, I need to figure out which quadrants y is positive. Good, that is quadrant 1 and quadrant 2, isn't it? Well, the quadrant 1 angle is always easy because that's your reference angle, so it's 1.04. And now you're like, well, how do I come up with quadrant 2? I don't know how to deal with the decimal. I deal with it the same way I've been dealing with it. I need to come up, since my reference angle is 1.04, from the x-axis. From the x-axis, I'm going into quadrant 2 by 1.04. But since I'm going clockwise, since I go against the labeling, that's a subtraction problem, isn't it? Which means to find your quadrant 2 angle, you're going to take 3.14, you're going to subtract the reference angle of 1.04, which means your theta in quadrant 2 is approximately 2.10. Interesting, huh? A little bit more work. You're like, oh, the calculator should have been so easy. It should have been. However, I have to follow my process. If they want my theta still in a full circle, then I need to come up with the quadrants. But to come up with the correct quadrants, I need to know which variable and if it's positive or negative, but I also need to know that reference angle. Got it? Okay, let's look at this one. Process hasn't changed. I need that tangent of theta by itself. So I'll get the tangent of theta equals -5/8. You with me? I'm going to the calculator because I need to see what that is. And when I go to the calculator, I get, oh, you have to take the tan inverse, right? So some of you, let's get this down for some of you. Sorry, because I know some of you want to see that. So theta, to figure out your theta, you have to take the tan inverse of -5/8. And when I did that, I got -0.56. Uh-oh. -0.56 is here in quadrant 4. You're like, how do you know? Label these things backwards. 0. This would be -1.57. This would be -3.14. This would be -4.71. And this would be a -6.28 if you go against the labeling. That's a quadrant 4 angle. The reference angles are supposed to be quadrant 1. So that means I went in the negative direction 0.56, right? So to go into quadrant 1, you are going to go in the positive direction 0.56. So guess what? In this case, your reference angle is positive 0.56. That was actually quite nice. Because this was quadrant 4, then it was easy for me to get into quadrant 1. All right, so now I still have to figure out which quadrant my answers are going to be in. So, tangent is x and y, isn't it? And in this case, I have a negative answer. So, I need one of each. I need a positive and a negative. So that's quadrant 2 and that's quadrant 4, isn't it? Okay, some of you are going to want to see my work, so let me get rid of some of these numbers over here on the grid system because they're just going to get in the way, and I don't want them getting in the way of you seeing how we're going to do this. Gratefully, I don't care about the negative angles anymore because we've already figured that out and taken care of it. Okay. Quadrant 2. I'm going to go from the x-axis, because reference angles are always from the x-axis. I'm going to go into quadrant 2, and when I go in this direction, I'm going negative 0.56. So to figure out the quadrant 2 answer, you're going to take 3.14 and subtract 0.56, which gives me theta is approximately 2.58. To get the quadrant 4 angle, again, I'm going off the x-axis. I'm going against the labeling by negative, right? 0.56. I have to subtract it. So in quadrant 4, I'm going to take 6.28 and subtract 0.56. Sorry, running out of room right there, which gives me approximately 5.72. So, almost the same, little bit of extra work, especially if the angle you got was not the reference angle, right? I suggest you rewind these two problems and look at them again, especially when I was working here on the grid system on the XY axis, so you could see how things were going. So you understand how these decimals are working on the XY axis. Cool? Okay, so you have fun with all these solvings of trig functions, and I'll catch you on the flip.